Good afternoon, students. Today we will learn about the new topic called as a super vector machine. What is meant by super vector machine and why it is being used and where it has been used. Today we are going to learn this. Now, super vector machine. A supervised machine learning algorithm which can be used for both classification or regressional challenges. So in the previous class we learned about two types of learning and two types of categories of data, that is a supervised learning and unsupervised learning. In a unsupervised learning we learned about a cluster analysis and the cluster techniques. Along with that, we also learned in the unsupervised learning what is meant by a regression, what is meant by a correlation, what is the difference between a regression and a correlation by using a scattered graph. Now, same concept, we are going to learn the regression and the correlation, the relationship between both of them in a machine learning algorithm by using a support vector machine. So, support vector machine is a supervised machine learning algorithm which can be used for both classification and regression challenges. Now, in this algorithm, we plot each data item as a point in n-dimensional space, where n is the number of features you have, with the value of each feature being the value of a particular coordinate. I'll explain this statement within a graph. Then we can perform classifications by finding the hyperplane line, or it is called as a differentiation between. We will learn this in a graph that differentiate the two classes very well. Okay, so what is mean by that hyperplane, what is mean by an n-dimensional space, and what is the value of each feature by using support vector machine. See, now you can see the graph carefully. There are two different types of variables. One is in a green color, one is in a red color, and also the green color is called as a vectors, or the value of the each future element with respect to x and y axis. This is called as a hyperplane line. I think you can see on a dashed line between two different types of variables. One is in a green color, one is in a red color. The relationship between these two, which is nearing to this hyperplane, is called as a support vector. Okay, so I think you can see here the dashed detour line, the red one and the green, okay, and the another green. These are the three elements. I think you can see three dashed lines, that is a support vector dashed lines, two from the green and one from the red, which is our nearing or mirror to the hyperplane. Then it is called as a supported vector elements, support vector values. Okay, so we will learn briefly. So identify the right hyperplane, that is how I can identify this dashed line, hyperplane. I think everybody saw in the previous line, this is the dashed line without arrow. You can see the difference between a green and red is a hyperplane. Now how I am going to identify the hyperplane is a major factor. Clear? Now how I am going to identify the hyperplane? See, now there are four types of scenarios to identify the hyperplane. Now the first one is identify the right hyperplane, scenario 1. Here we have three hyperplanes. You can see one is a solid line, two are a dashed line like A, B and C. Now identify the right hyperplane to classify the stars and circle. You can find it both are looks like even a circle with a red color and green color in the next image. I think here you can see this is also called as a scenario 1. Can you everybody see this graph? There is a three hyperplanes. One is A line, solid line, one is a B line, one is a C line. Now there is a two support vector elements. One is in shape of star, one is in a shape of circle. Now the differentiation between, or the correlation between, or to make a relationship between stars and the circles, I am going to identify the hyperplane. This is the scenario 1. There are three different hyperplanes called A, B and C. Now you need to remember a thumb rule to identify the right hyperplane. That is, select the hyperplane which segregates the two classes better. Understand? Please underline. You have to select, you can see in the double quotes I mentioned, select the hyperplane which segregates the two classes better. You can see A and you can see A, I think most of the stars are one side and little bit, I think 5 circles are at the above. If I identify the line B, I think it has sorted out clearly. If I see the C, it is a partial. Stars are little bit are above and below, and circles are also above and below of that hyperplane. So what we want to do, how we are going to identify means, select the hyperplane which segregates the two classes better way. In this scenario, hyperplane B has excellently performed the job. You can see now, if you see A and if I see A, there are some red color circles above the A line and below the line. If I see the hyperplane C, there are all the stars are above the C line and some of them, 2 are there from above the C scattered hyperline and below all the red color are there. But whenever I compare B, exactly all the stars are at the left side, exactly all the circles are at the right side. So when I compare A, B and C, in this graph, B is an excellently performed this job by segregating the two classes perfectly without any interrelated. Understood the scenario 1? So in this diagram, I can say B has segregated the two classes better compared to the hyperplane A and hyperplane C. Clear? Fine. This is the scenario 1. Now we will go with similarly here. Same thing. Can you see? I didn't mention, this is a graph, I didn't mention the hyperplane A, B and C. Okay? But all the three are same. Clear? But it is not. But actually, you cannot consider it. Now, how we to box? The thumb rule of hyperplane always segregates the two classes better, and keep one more point in you. Maximizing the distance between nearest data point and hyperplane. The distance is called as a margin. So my dear students, you can see here. Whenever I see the objects of an stars and circle, see the distance. So whenever I say B is in a best, what is how many support vectors are nearing to B? That matters. Clear? If I say there are how many stars are there in a graph? 9 stars are there. Here how many circles are there? There are 8 circles are there. But when I see the scatter line B, how many stars are nearing to it? I think hardly 2 stars. Okay. Similarly here you can see how many are there nearing to it. Maybe 2 or maximum 3 circles I can say that they are nearing to the B side. So what I want to conclude, always see it should segregate the two classes better way, and also maximizing the distance between the nearest data point, that is the either of the class, either a stars or it may be in a circle. Then hyperline, that distance is called as a margin distance. So in this way we have to identify the hyperplane to segregate the two classes. Okay, this. Now this is the second. Now we will learn the scenario 2. Now scenario 2 is here. We have 3 hyperplanes A, B and C, and all are segregated the class well. Clear? Yes, all 3 are looks like a parallel lines. Now how we can identify the right hyperplane? Clear? Now here maximizing the distance between the nearest data point, that is the, and hyperplane will be used to decide the right hyperplane. The distance is called as a margin. Let us look at them below snapshot. Now my dear students, first scenario is clear. Both are segregated in a better way. A and B and C both are sorted out. All the stars are the above and all the circles are the below of each hyperplane. But in these three, which is the best one? Okay, that is our